morning, good afternoon, good evening. Take my greetings according to your timing. I am Ayushi Sarkar from ECE department and going to teach you your signal system. So this time I am with the topic periodic and non-periodic signal. Before I start with the topic, I hope you remember what I have made you studied on the last few classes. And yeah, I'm sorry that I am uploading the lectures after a very long time, so I'm extremely sorry from my end. So I have taught you about odd and even signals at my last lecture and their properties as well. So today I am with periodic and non-periodic signal. So what do you mean by periodic signal? So basically, when a signal repeats itself after a regular time interval, it is known as periodic signal. And yeah, you can understand that non-periodic signal don't repeat after a regular time interval. Okay, so this is the fine difference between the periodic and non-periodic signal. So let me take an example for you. Okay, so for an instance, let's take xt is a signal that repeats itself after 5 seconds. Okay, so here if you see that xt repeats after 5 seconds, when we take xt as the fundamental signal, and then we can see that xt again repeats after xt plus 10 after 10 seconds. Okay, so from what you can see here you can see that xt plus n minus 1 by 5 is equals to xt plus n5. Okay, just see this and this. So from here you can deduce that xt is equals to xt within bracket t plus minus n t naught. And what is this n? This n is basically the integer, and this t naught is going to be our fundamental time period. So how can you explain this in your own words? So you can say that fundamental time period can be said as the smallest positive value of time after which the signal repeats itself, or you can say that the signal becomes periodic, and this value is constant for the whole signal. So I hope you understand from here. How can you explain it? So for this is this term, this term is for continuous time signal. When we are talking about the discrete time signal, we have to keep in mind that our xt, see here, so here this time not xt, this is our xn. Okay, so this xn changes into xn plus m into n. Here m is the integer, I hope you understand. Okay, and n is the fundamental time period. Okay, this n is the fundamental time period, therefore this fundamental frequency is going to be 1 by n. Okay, so for this again I am telling you, for fundamental frequency for cts, continuous time signal, is going to be f naught is equals to 1 by t naught. I hope you understand. And again omega naught, which is the fundamental angular frequency, that is going to be our omega naught is equals to 2 pi f naught. Okay, and from there you can say that omega naught is equals to 2 pi t naught. So here you can say that omega naught is inversely proportional to t naught. That means angular frequency is inversely proportional to the fundamental time period. Okay, let me take an example of what? Example of sine theta. Because sine is a periodic signal. How can you say that sine is a periodic signal, and where does it becomes periodic? See, I am just writing it over here with my highlighter. See, here the signal is coming. Okay, so you can see this part at pi, it is not repeating, right? It is not repeating here. This signal from here 0 to pi is in positive half, and then pi to 2 pi is in negative half. That means that this signal is not repeating at pi to 2 pi as well. Okay, that means they are not periodic in nature at pi is equals to at time period is equals to pi. That means we have to take another instance. Let's take time period is equals to 2 pi. Okay, there we take this whole sum of signal. This is our 2 pi. Okay, then when we start repeating this signal completely, we can see that yeah, here from 2 pi to 4 pi the signal is repeating as it is. So we can say that here the time period t naught is going to be 2 pi. I hope you understand. Okay, so this is the whole instance that I have told you. So I don't think that you have any doubt with it. So let's move to the next topic. Not the next topic, this is actually a parallel topic that you need to understand. Okay, and for that, what do you need to study? You need to study two basic things. So let's move to them. Okay, another important point that I was going to miss, that DC value is a periodic in nature. How am I saying that DC value is periodic in nature? When I will start giving you example, you will find, but still I'm explaining you over here as well. See, let's take a DC value of 2. Okay, so this is our common DC value of 2. Okay, this is our DC value. See, here we are not finding anything. If we will add anything such as 2 plus anything, so it is going to be constant, right? So this is completely a constant figure. It is repeating itself again and again till infinity. It doesn't have it is basically independent of any kind of change with the time, right? So this is basically also considered as periodic in nature. Generally we overlook it and consider it as a periodic because it doesn't follow the equation, but remember, DC value is periodic in nature. So the most means like question answering part comes from T naught, finding the value of T naught. Then what is T naught? This is our fundamental time in period. Okay, that I have already told you. So let me introduce you with some few things. I hope you know the Euler's equation. I don't think that you are not able, but still I have written it over here. Let's explain this Euler's equation first, then I will move to the main part. So what does the Euler's equation say? That e to the power jx, okay, is equals to cos x plus sin x. Okay, so if we put x is equals to 2 pi k, that means cos x is equals to cos x 2 pi k plus sin x 2 pi k. Okay, so that means e j 2 pi k is equals to 1. Okay, how? C 2 pi k is 1 and sin 2 pi k is going to be 0. That means that e to the power j 2 pi k is equals to 1. Basically, you know what is the Euler's equation? You just need to keep in mind, it is going to get repeat again and again, I am telling. So please I am marking it once again with the highlighter. Please remember this very well. Euler's equation is important for signal and system and more the parts that are going to come in future in your subjects. So let me take the instance of a signal. Okay, so I'm taking a normal signal. Okay, let's take this blue pen. Okay, xt is equals to, this is our amplitude a naught. Okay, e to the power j omega naught t. Okay, so when I take e to the power j omega naught t, and then we say just adding plus t naught, this is our fundamental t naught. Okay, then we are doing what? Xt plus t naught is equals to what? We will add this t naught to here as well, this time period as well. So here you see e to the power j omega naught t plus t naught. Okay, so once we do this, we get what? Here we are taking this instance. See, this a naught j omega naught t. This one, as it is periodic in nature, we are taking this. We are just equalizing xt is equals to xt plus t naught, because this is periodic in nature, right? So see what we are doing this. And when we are doing this, we will equalize which part? This part as well. A e to the power j omega naught t with what? A not e to the power j omega naught t plus t naught. So here you can see when we equalize it, that amplitude will get cancelled because it is same. And once when we do that, what? E j omega naught t here, and here you know one property, right? Okay, let me erase this first. Too much, yeah. So you know one property, the property says that e, okay, wait just a second. Here a to the power b plus c is equals to a to the power b dot a to the power c, right? I have used this property over here. Okay, just after using this property, when I use this property, you can see that what it turns to be, e j omega naught t is equals to e j omega naught t e to the power e j omega naught caps t naught. That means fundamental one. Here you cut it with this. Okay, it get cancelled, and then finally what we are getting? We are getting that e j omega naught t is equals to 1. Okay, and we know that 1 is equals to ej 2 pi k. Okay, that's why I have directly written e to the power j 2 pi k over here. So here you get the final answer, and just you have need to do what, you will just equalize omega naught t naught with 2 pi k. So here you will equalize omega naught t naught with 2 pi k, and there you get t naught is equals to 2 pi k by omega naught. Okay, so after all this stuff, when we put a k is equals to 1, then you get t naught is equals to 2 pi by omega naught. Please, I'm writing this stars again and again, because afterward when I will move to the question solving part, means like you will see different kinds of effects of different kinds of shifting and all in this, then you will understand what is the value of this equation t naught is equals to 2 pi omega naught. Okay, I hope you understand. Just go through this once and then only move to the next part, else you won't be understanding what's going on over here. Okay, so let's solve some questions with me. Okay, I will give a homework question as well. So when I write, let me take a pen, different pen. Okay, here the question says that find t naught and f naught for the equation xt is equals to sine square 4 pi t. You know what? You know equation. This is not, this is just algebraic equation. Okay, you know that cos 2 theta is equals to 1 minus sine square theta, right? So just the way we solve our equations at past earlier, so we need to do what, we just need to find out sine square theta from here. When we write sine square theta, it is basically 1 by 2 into 1 minus cos 2 theta. Fine. Okay, so this is our equation that we get. So here you can see that theta is equals to 4 pi t. Okay, and once you get theta, I hope you understand that it revolves like this way. xt is equals to sine square 4 pi t, right? And we are just introducing this one here. Okay, how will I write this? 2 theta 1 by 2, 1 minus cos 2 into 4 pi t, that means 8 pi t. Okay, so this is what we get. So after all this stuff, just do what, just separate them. How will you separate them? See, let's take xt. xt is equals to 1 by 2 minus cos 8 pi by 8 pi t by 2. Okay, see, this is our what, this is our dc value. This is our what, dc value. So you know dc value is always periodic in nature, so I am not writing it again. So this is our dc value. Whatever we will play with this term. Okay, so here you can see 8 pi t by 2. So clearly you can see here that omega naught is equals to 8 pi, right? Because we know what, this is our cos omega naught t. So omega naught is equals to our 8 pi. Sorry, I have written 2 pi here. This is going to be our 8 pi. Okay, this is our 8 pi. And once we say that t naught is what? From this equation, see this, why I said you that this equation is going to be very important when I start solving. This is equals to 2 pi by omega naught, right? So from here you can deduce that 2 pi by 8 pi. So this is our 1 by 4, right? That means t naught is equals to 0.25 seconds. Okay, and this is our fundamental time period for this question. Xt is equals to sine square 4 pi t. Got it? So let me take another example. See, before I start this example, another thing I want to write. So please write it with something highlighting. Okay, I'm writing it with yellow, my favorite color. So xt can be written as in the form of x1t plus x2 t1 t2. Okay, like this way. So see, this is also the same thing. For this you need to understand some factors. So for one, here we are taking x1 t as sine 6 pi t and x2t. Okay, let me write it x1t first, then I will be continuing with x2t. Okay, as I write here, so you can see 6 pi is our omega 1. So omega 1 is equals to 6 pi, right? So as omega 1 is equals to 6 pi, t1 is equals to what? 1 by 3. Okay, so clearly you can see from here. So once I get this, let's write x2t. x2t is our x2t is equals to cos 5 pi by t. Okay, 5 pi t. Okay, sorry, sometimes I get muggle up with my handwriting, bear with it. 5 pi t. Okay, so once I get 5 pi t, we will do what? We will just take omega 2. Omega 2 is what? Omega 2 is equals to 5 pi, and then what we will get? T2 is equals to our 5, sorry, 2 by 5. Okay, why 2 by 5? I hope you understand, because t1 is equal, t is equals to 2 pi by omega naught. Just you have to put the value. Pi cancels out and it turns to be this. See, here are some factors you need to keep in mind. So once we do this, we will take the ratio of t1 and t2. Once we take ratio of t1 and t2, we get what? 1 by 3 by 2 by 5, and it turns to be 5 by 6. And I think this is a rational number. Not I think, I am sure this is a rational number. Okay, so as it is a rational number, okay, so what is our t naught? Main, this is the key thing you have to write. T naught is equals to LCM of t1 and t2. Sorry, t1 and t2. Okay, this is the highlighting point. Mark it with something before moving when you are getting. Okay, this is our point, you need to understand. So once you get this, so just solve it. Okay, that is, you will take LCM of whom? You will take LCM of 1 by 3 and 2 by 5. Sorry, 2 by 5. So once you take LCM of this, what turns to be is our 2 3 is going to be our 15 in, and here it turns to be what? 5 minus 3 2 again it's going to be what? 2 minus 6. Okay, so this is our LCM of 1 by 3 is going to be 2 5. So after that, when we take this, you will have to think another thing as well. How will it calculate this LCM? So for calculating this LCM, you can use a trick that is going to be T naught is equals to LCM of 1 comma 2, okay, and HCF of HCF of 3 comma 5. Okay, so after you do this, you will get what? LCM of this is going to be 2 and HCF of this is going to be 1. Okay, so after this you get T naught is equals to 2 seconds. Okay, this is a bit complicated, but I hope I have made you understand, and if not, then I'm sorry from my end, but I will just request you to go through this once again. Let me explain it with you once again so that you can understand it. See, we are taking a signal xt in the form of two another signal sine x pi t and another cos 5 pi t. Okay, once we take this, we are taking x1t is equal to sine 6 pi t and x2t as cos 5 pi t. Okay, and here we see that 6 pi t is equals to omega 1 and 5 pi t is equals to omega 2. Okay, here we solve and we get t1 is equals to 1 by 3 and t2 is equals to 2 by 5. Once we get this, we are going to take the means like we are going to take the means like we are going to t1 and t2 in the form of fraction. Okay, so once we take their ratio, t1 by t2 is equals to 1 by 3 by 2 by 5, and there you get 5 by 6. Okay, So this is a rational number, and once we get our rational number, we will do what? We will find LCM to get the T naught. So for the LCM of T naught, we will do LCM of 1 by 3 and 2 by 5. So it's very difficult to do the fractional LCMs, to take LCM of the fraction. So to find LCM of the fraction, we do what? We will just do LCM of the numerators divided by HCF of the denominators, and by this way we get 2 by 1, and that's the our final answer comes to be T naught is equals to 2 seconds. Okay, I hope this is a bit clear from my side. So without further wasting time, let's come to the next topic, that is our effect of time shifting and time scaling. Okay, what does this time shifting and okay, see, I hope I have already find out T naught. It's not easy to find out F naught. What is our F naught? F naught is equals to T naught. Okay, this is our, okay, and this case is also same. This is our F naught is equals to what? F naught is equals to our 4 hertz. Okay, because this time we have already done this. Okay, I'm sorry, I have forgotten to do this. So let's take the effects. So before I move to the effects, I hope you understand all this, clear all the topics, then move forward. Don't do this like you are jumping up to different topics and not understanding anything. Okay, so wait, yeah, so once you get it, x naught t is equals to sine 2 pi t. This is just a signal. This is a normal signal because this is sine 2 pi t is periodic in nature, you know, right? So for that's why I'm taking this signal. So once I take this signal, you know that I will just do what? This is our sine omega naught t. From here you can write that omega naught is equals to our 2 pi. Okay, then you can say that T naught is equals to 1 second. I don't need to repeat this. I have already repeated it thousands of times. Okay, see, for this time I am taking time shifting. I hope you remember what was time shifting. Time shifting is adding a certain time with the fundamental time t plus 2. Okay, so how will you do this? This is going to be our x1t is equals to x naught. What was x naught? X naught was sine 2 pi t. Okay, sine, there you do what? 2 pi. Instead of t you will write t plus 2. Okay, you write here t plus 2, and then you continue writing sine 2 pi t plus 4 pi. Okay, so here you can see that this is in the form sine omega naught t plus phi. There is a certain angle called as phi. So you can see that t naught doesn't change because t naught depends on what? Omega naught. Omega naught is not changing, right? The change is in the phi. It is adding a certain angle. It's not changing. So you can say that t naught remains same. T naught is equals to 1 second. Therefore, you can write with a clear color that t naught is independent of what? Time shifting. Okay, I hope you understand this portion. Okay, let's take time scaling. What was time scaling? Because I am doing this fastest to cover all the topics in one video. That's why. I hope you understand. So let's take this x2t. So this time when I take x2t, so we are taking what? Sine 2 pi. Okay, multiplied by 2t. Okay, instead of t. So this time we will do what? Sine 4 pi by 4 pi t, and here this is in the form of something like this 4 pi. Okay, this 4 pi means what? Omega naught changes over here. That means our t naught will also change, and this t naught changes as 2 pi by omega naught. What was omega naught? Initially it was 2 pi, and here now it becomes 4 pi. So we will put 4 pi, and here we find that t naught turns to be 1 by 2. ठीक है? So finally we get what? T naught is not independent. Okay, and how it is dependent? So write it with a very beautiful color so that because see, these are the small things that are very important for your exams. Okay, so T naught in this case is not independent. Not independent of time scaling. And how it is dependent on time scaling? Just see, let's take an example. Xt is having t naught as its fundamental frequency, and if we do x something say as alpha t, okay, then we will get what? We will get t naught as t by modulus of alpha. Okay, and always remember this alpha is going to be positive. Okay, not equals to 0, not equals to infinity. Okay, I hope you understand. This is a very good thing to understand. This is a easy topic. Okay, so I'm not wasting much time on it. So, okay, so let's move to the next one, the time reversal and phase shift. Okay, so when I'm talking about time reversal, I hope you understand what is time reversal. This minus. Okay, I'm highlighting it. That's why. So time reversal. So in this case, we will do what? We will just take this x. Okay, see, I'm not taking x naught over here. Let's take x1. Okay, because sometimes we need to understand. No. Okay, let's take this only, because see, here you will do what? X3t is equals to x naught minus t. Okay, so for this you will do what? You will just use sine minus 2 pi minus t. Okay, here. Okay, this was the thing. So when we get this, we will do what? We will just recognize some few points that you have already learned. So the few points are like this, that minus always being carried out at the beginning. Okay, 2 pi t, 2 pi t. Okay, sine 2 pi t. The minus comes out. Okay, but the omega naught doesn't change, right? The omega naught remains to be same. So the t naught is going to be same, like 2 pi by omega naught is equals to 2 pi by 2 pi, and this is going to be 1 seconds. So the fundamental value doesn't change. As the fundamental value doesn't change, that means it is independent of time reversal. Okay, so I'm just doing what? I'm just copy pasting it from here, because it will take much time to if I start writing. So let me copy paste. Okay, time. Do what? Time reversal. Okay, I hope you understand. Let's take phase shift. So what does this phase shift means? See, phase shift means a shift of some certain angles. So I don't think it will change or affect your omega naught, right? The omega naught is going to be same. First phase shift of 45-degree. I think you have seen this here as well. This is what this phi is, basically phase shift, right? It. See, what you will do? We will write x4 in the form of normal sine 2 pi t plus 45-degree. Okay, this is basically means what? Sine omega naught t plus phi. Okay, this is in the form of this. So this omega naught and 2 pi doesn't change. Just there is an introduction of new angle. That means t naught is again independent of phase shift. I hope you understand. Right. So here also I will just copy and paste. T naught is independent of what? Independent of, sorry, independent of, independent of phase shift. Okay, so done. These are what we play with time and angle. Let's come to the point of amplitude. Okay, what was there in amplitude? When I talk about the amplitude, it is basically effect of amplitude shifting on T naught. So what was the effect of amplitude shifting? So basically there is no effect, because you see omega naught is not changing. So this is also independent of this. See, how do you find that this is also independent of this? So basically we do what? we are having 1 plus x naught t, but here t naught is not changing, right? T naught is 2 pi by omega naught, and it is remaining same, 2 pi by 2 pi. Again, I'm not writing, so just bear with me. Okay, 1 second. Okay, that means this is also, here paste t naught. T naught is independent of amplitude shifting. See, where you see the change in omega naught, there is a dependency, and where you can't see any change in omega naught, it is simply independent. Okay, so this is independent. Fine. And then we come to the next topic. So here, this is our 2x naught. So when we say that this is our 2x naught, we do what? See, we take, let's take this, xt is equals to 2 into sine 2 pi t. Okay, so see, this omega naught was again not changing, so t naught remains to be same as 1 second. And again I am going to write this, yes, as t naught is independent of amplitude scaling as well. Amplitude scaling. Okay, so last and foremost is amplitude reversal. See, when we do x7 t is equals to minus sine 2 pi t. Okay, that means t naught is again not changing. So here 2 pi by 2 pi is going to be 1 seconds only, and here you can see that t naught is independent of amplitude reversal as well. Amplitude reversal as well. Okay, I hope you understand, and this is what we end up with. And see, we have a question, homework question. This is our homework question. You will try this, and you just pause and try, and I am doing it and solving. Just match your answers after that. Okay, how will you solve? See, we take xt. Okay, xt is our t naught. Okay, I'm not writing. T naught is going to be our 16. Say, let's say. Okay, let's don't write here 16. Okay, 16. And here we start doing what? One by one thing. xt plus 9. You know what? Shifting doesn't have any effect. We have already write this independent, so it will remain in t naught only. And then when we will do scaling, we will do what? Scaling. So we will do 2. Sorry, I will should do scaling first. Sorry, I had a mistake. X, I will do scaling first. Okay, as I do scaling first, this t naught becomes what? T naught by 2. Okay, so that means some glitch is happening with my tab. I'm sorry for all this. Just give me a second to fix all these things. Just a second. Yeah, so here we comes with what? xt, that is 2t basically, because we will do the scaling part first. Time scaling. So you know that it has a certain effect, t naught by 2. Okay, that means this turns to be our 8 seconds in this step. Okay, and then we do what? X 2t plus 9. You know that time shifting doesn't have any change, right? Sorry, let's say minus. Let's take the reversal as well in this step. You know the reversal doesn't have any effect, time reversal. So as it doesn't have any effect, this remains to be same. And then we do what? We do time shifting as well. 2t plus 9. This is our time shifting. As time shifting is also not having any effect on t naught, this remains same. So finally we get yt is equals to x minus 2t plus 9. Okay, is having time period T naught is equals to 8 seconds. So this is our answer. So thank you for watching. I am very sorry once again that I couldn't upload lectures regularly, but I will try to upload it. And so let's meet on the next lecture. Bye bye.